an introduction to our project, it provides a digital platform that focuses on book borrowing and returning. It also offers a vast collection for users' convenience. Other than that, it provides an efficient tracking system that allows for accurate monitoring of borrowed items. After that, there's also a systematic organization which promotes orderly management of library resources. It also has automation goal which aims to automate borrowing, returning, and managing process. Users can search for books that they want to borrow online and facilitate the borrowing through computers. It also provides a transaction recording system which checks for availability and transactions which are recorded digitally. It provides an enhanced user experience which improves efficiency and users' interaction within the library. Last but not least, it provides a minimal manual effort which reduces workload for library staff and borrowers. Problem statement. Libraries often struggle to keep track of their books, magazines, and all sorts of reading materials. Other than that, managing the records of library users and their borrowing history can be troublesome because it mostly has to be done manually. After that, it requires a lot of time to borrow books because the user needs to queue long. Last but not least, users have a hard time when searching for the books they want to borrow. Our objective for building the system is to develop an easy-to-use system where users can search for books, view the description of it, and make a booking to borrow the book. Other than that, it is to provide a functional borrowing system and to keep track of users' registration information and borrowed books details. Last but not least, it provides up-to-date information to patrons on the book's availability for borrowing. The significance of the project is this system will help users borrow their book through an online platform, and it enhances the overall user's experience because it is easier for them to search and locate the book. This system also helps the library administrators by having a check-in and check-out function, so by doing that, it will reduce the book's disappearance.
Hi, my name is Wanur Aisha and I'll be presenting about entity relationship diagram and business rule. So what is ERD? ERD is like a map that shows how different entities in system are connected. It helps understand the relationship between these things and make it easier for us to design and organize system. And business rule defines the constraint or condition that must be satisfied within a business process or system. For our ERD system, we have a total of 10 tables including 2 bridges. And as you can see here, this is our ERD table. I'll take book list table as an example. The book list table is a bridge that contains 2 primary key and 2 foreign key, which is book copy ID and borrow ID. This means it's connected to book copy table and borrow table. For the book copy table, the primary key is book copy ID and the foreign key is book ID. The business rule between these two is each book copy is included in one or many book lists, and each book list includes a book copy. For the borrow table, the foreign key is patron ID and employee ID, and the primary key is borrow ID. The relationship between book list and borrow is each borrow has one or many book lists, and each book list belongs to a borrow.
Data dictionary. Okay. So in a database, a data dictionary serves a crucial reference guide documenting the structure, relationships, and the attributes of the data. It enhances communication between stakeholders, ensures data consistency, and facilitates efficient database management. It also, without a data dictionary, navigating and understanding the database can be challenging, leading to errors and inefficiencies. It's an indispensable tool for maintaining data integrity and promoting collaboration between database users and administrators.
Database implementation. Did you know the purpose of database implementation is to organize and store data in structured way? This make it easier to manage, retrieve, and ensure its accuracy. And as you can see here, we got patron, book, and borrow table. The data that were inserted in all these tables were based on the data dictionary. I'll take the patron table, which is patron name, as example. As you can see there, Wan Aisyah binti Wan Zaidi were based on data dictionary, data type and size, which is char 5.
My name is Noor Edina. I will be presenting the SQL data manipulation language of insert, update and delete. Inserting can be done after we create the table that we want. After that, as we can see above, we can insert the values by writing an SQL statement. There's a lot of ways to insert the data. One way is to insert the table name, and in the brackets we can put value 1, value 2, value 3, etc. This way you can add new data for all columns without specifying the column list. Examples can be seen above, like the book table and the book list table. For the update statement, we use it to modify the data in an existing table. We can update all rows, update multiple columns, and update specific rows by using the where clause. For example, we want to update the quantity of the book with the ID PK0001 to 600. By using update book, set book quantity equal to 600 where book ID equals to PK001, then the rows we update the book quantity from 500 to 600. We move to the delete statement. It is to delete the data from an existing table. We can delete specific rows or all rows. In this project, we use it to delete the boot copy with the boot copy ID 1234AC by using delete from boot copy where boot copy ID 1234AC, then the row will be deleted.
Relational algebra and select statement. In SQL, the selection and projection operation are typically achieved through the select statements, especially the where clause for selection and select for projection. As you can see the example here, we use select and where statement to achieve the specific data of book ID from book copy table. And the next is aggregation and grouping operation. Grouping is basically organized data into groups based on specific columns, and aggregation is used to apply function to values within each group to obtain summary, statistic, or calculation such as sum, maths, and mean. And take a look at the example here. We use the select sum statement to summarize the payment amount.
In database design, understanding inner and nested queries is essential. Inner queries filter data within a specific condition, optimizing retrieval. Nested queries, or subqueries, provide a way to perform complex operations. By this approach enhances flexibility and supports more advanced data manipulations. Mastering inner and nested queries empowers users to extract targeted information efficiently, making them indispensable tools for optimizing database performance and handling intricate data scenarios.
Conclusion of the presentation. We target for our system to contribute on making the process of borrowing and returning books easier and much more efficient for both the library employees and the patrons. This system keeps track of the borrowed books, due date, and the patron's information, making the lending process more efficient. However, there are a few drawbacks of our system when it comes to handling data during transactions. First, there's a risk that the data might not stay accurate or consistent. It is not easy to build a strong and reliable setup for the system data, and mistakes in linking data or running searches can cause wrong information to show up. For future improvement, the system could keep a record of what books each person borrows and suggest new books they might like. It's also important to have a good backup system to protect the data.